All right, so we are going to be able to use the product of powers property for exponents and the quotient of powers property to simplify our expressions. So this is going to get into more of the complicated ones. So we're going to go through example A together. So it says simplify 2x to the fifth times 5x to the fourth. Now, the biggest thing that I see students trying to do is they group 2 and x to the fifth, and they group 5 and x to the fourth. Those coefficients do not belong to those variables. Okay, I can rewrite this as 2 times x to the fifth times 5 times x to the fourth. The 2 does not belong to the variable, the 5 does not belong to the variable. So we can rearrange our multiplication because order doesn't matter for multiplication. So I want to multiply my coefficients first. So it'd be 2 times 5 times my exponents or my powers with the same base. So x to the fifth times x to the fourth. Well, we can do 2 times 5, which is 10. And like we saw in the previous video, if I'm multiplying powers with the same base, I can add their exponents. So this becomes 10 to the 5 plus 4. So this would be 10 to the x times x to the ninth. So that simplifies. So let's do some more. We can do this with my quotient property as well. We want to first rewrite this just with all of my multiplications. So 2 times x to the fifth times y to the fourth over x times y to the second. The 2 has nothing to simplify with, so it just becomes out in front. I'm going to group my like bases. So times x to the fifth over x times y to the fourth over y to the second. Now, when a variable doesn't have a power, it really does. If it doesn't have a power shown, it's really a 1. So I can rewrite this with my quotient property says I need to, if I'm dividing powers at the same base, I can subtract the exponents. So this becomes 2 times x to the 5 minus 1 times y to the 4 minus 2. So this would be 2 times x to the fourth and then y to the second. And that would be what it is simplified. Let's do these together as well. If you want, you can try pausing. Oh, whoa. You can try pausing the video here and then come back to see if you got it correct. Or you can just work through it with me. Now, remember numbers in parentheses next to other numbers in parentheses, that just means multiplication. So this is really just 4 times x times y to the fourth times negative 2 times x squared times y to the fifth. I'm going to group all my like bases together over here. I should move more of an arrow. So we have 4 times negative 2 times x squared times y to the fourth times y to the fifth. I have everything. So 4 times negative 2, that would be negative 8. When I'm multiplying powers at the same base, I add their exponents. And again, if a variable doesn't have a power, it does. It's 1. So this would be times x to the third, and then adding the y's times y to the ninth. So that would be that one. And you don't have to write the little multiplication symbols. You can if it helps you. So then let's use our quotient property. So again, grouping all my like terms together. So I get 2 divided by 4 times a squared over a times b to the fifth over b squared times c over c. 2 over 4 simplifies to 1/2 times, when I'm dividing powers with the same base, I can subtract their exponents. So this really is a 1, so this would be a to the 2 minus 1, and then times b to the 5 minus 2, times c, 1 and 1 still, 1 minus 1. So that simplifies to 1/2 a to the first power, or just a, b to the third power, and then 1 minus 1 is 0, and so those actually get canceled out. So this would be my final answer for B. And then let's do the same thing with C, grouping my like terms together. So I have 6/18 times 2, we can put that over 1, times, this is really all over 1, so x over x times y to the third times y. 2 times 6 is 12, so we get 12/18. X divided by x is 0. When I'm multiplying powers with the same base, I can add their exponents, so this becomes y to the fourth. Simplifying the fraction, 12/18 simplifies to 2/3, y to the fourth. So we have 2/3, y to the fourth. So that's our final answer for that one. Let me know if you have questions, and we'll go over this.